welcome back to my bench. Hey, today we're going to build a little kit. Well, it's a board that I did in Kicad for a stereo in, left and right in to composite output. I've been getting a bunch of these STLs to fix, studio transmitter links to fix, and I decided I had to have an input and an output to be able to take left and right in and get composite out to be, including the 19 kilohertz carrier for stereo. So here we're just going to start putting in the lowest components on the board. The board was by JLCPCB. They did a wonderful job for me. It looks very good. No errors that I can see. We'll find out once we fire this thing up, which we're not going to do in this video. This one's going to be long enough just putting the thing together. I did try to get rid of the top of my big fat head. I didn't have the camera set in the right spot, and when I recorded this, as a result, my head's in the shots a lot, so there's a whole lot of cut shots here. But you're not missing much. When I'm soldering or desoldering, I try to cut my head out. Here we're going to put in capacitors R1 and R2, or resistors R1 and R2. They're both 1K. I'm using 1% because I've got a ton of them. I bought, a long time ago, I bought a big bag of the things and separated them all out into these ohmite boxes, which I was lucky enough to find online for a reasonable price. Anyhow, there's no need for these. These are 1K input resistors. They don't have to be 1%. And we really don't know if this thing's going to work. I breadboarded it up and it worked. So, there's is a good guess anyway. But I don't know if you guys have ever sat down with a CAD program and designed a PC board, but doing the schematic isn't all that difficult, but doing the PC board itself, laying the parts out, is a little bit more. So now we're going to go for R3 and R4. These two are 50K a piece. I'll check. I've got a little box of resistors that I've had around for a while. One of these Lorenzo or Joe knows, one of those guys. And I'll check in those first before I go into my ohmite boxes there. If I've got them, I'll use them. If not, we'll use what we can. If we don't have any values that are exactly the same, like I think these are 51Ks. I think the closest I could get was 51 or 50. I don't know. Anyway, it's not super critical in this section of it. So, yeah. When I built or designed the board, I tried to go through and get the right sized resistor, all the components, layout on the board. And that is the hardest one to do because the Kicad's layout, parts layout thing is, you got resistors, you got 27,000 different kinds of resistors, and all they give you is the part number of the resistor, which usually includes the size, but there's so many different variations out there that you got to do a lot of research just to find out what templates you want to use for that resistor or that capacitor or whatever else you got. There's a couple of things I made a mistake on this board for the pictures. The parts layout diagrams, because I couldn't find the one that even came close. And these are just really bog standard parts in here. Well, there's those two. What's next? I guess, R7? Yeah, up by that cap. And R7 is going to be, a 1.8K? Yep, not in the bag, not in that box. So we'll have to get another one. Yeah, 1.8K, I think. Yep, there we go. Big fat head. Sorry, missed that one. When I do these things, I gotta remember to put the camera ahead of me, pointing down and towards me a little bit, so that I can't lean into it, because I have to be able to lean into it to see it, because I'm old and my eyes are going, and it's my hair turned white a long time ago. I forgot to get rid of that part. Oh well. What's next? So we're going for R8. R8 is what? I don't know. I'm looking at the schematic over here to see if I can find this stuff as we're going along. Yeah, 5, 6. It's 1K. It's over on the output, off of the transistor that's in here. I'm sure I got 1Ks in there. Yep. Honest, I did try to get rid of my big fat head in a lot of these shots. The ones that take any time. Yeah, people have been sending me in some things to repair that are just require that I have a little more equipment than I have, and some of it is kind of specific stuff to radio that you can't just go out and buy. You have to actually make. So what are we doing next? That one there, that would be R5. And R5 is 38K. And I think I have to go yep, there we go. Not a standard, comes in a box size, but I got them. I've been collecting parts and stuff for quite a while. But when you go to fix something, of course, you never have the actual part you need. That's to be expected. All right, what's next? Not quite perfect. What's next? What do I want to do? Yeah, let's do that one up there. That's going to be what? Another 38K? 39K for R6. Yeah. We're just going to go with 38. That is the output going to the level, the output level resistor, potentiometer. So it's not critical. Just keeps you from taking it all the way to ground. All right. What's next? Let's see. Yeah, we'll get this one up here. What's this one? Actually, I think that's all of those. Well, let's do some capacitors. This is my box of caps. All kinds of different little ones. Some are poles. Most are new. Some of them are poles. Let's go for those ones in the front end there. That would be C1 and C2. Those are 1,000 picofarad, each one of them. So we want 1,000 picofarads up there. I guess I use these little guys. They're pretty stable, and they're cheap. You could. Back when I bought these things, they were pretty cheap. But nowadays, my word, everything costs a fortune. I do a lot of work on 528Es, if you guys have seen my channel, and the capacitors for those, just the cost of the capacitors has more than doubled in the last year. So parts are getting much more expensive. I don't know if that's just because of supply line stuff or what, but it's kind of taking a toll on repairing things. Got to take your price up if you're going to do something. If your cost of your parts doubles. Okay, let's get let's get C3 and C4 here, and those are going to be 0.1 microfarads. This one's got a whole bunch of different sizes. We're going to go with the same type of thing, 104s, for this. See, I don't know if you can see that, but yeah, it's 104. Be neat, put everything back. Try not to make as much of a mess as possible. Okay, those guys are in. Focus. Thank you. Yeah. Autofocus. I tried setting a focus just for the bench one time, and it didn't like that very well. I use my little Sony camera up here, and it's fixed focus isn't all that great. When you do that, then it starts hunting for light. It's weird. Anyway, some people have asked me to show what I use from start to finish for making videos. Maybe I'll get to that one of these days. What do we got next here? Let's see. Okay, let's that would be C11 or C13. C11 would be 510. Let's go for that one. That's 510. This one's kind of critical. This one's going to be part of the 57 kilohertz low-pass filter. And it's part right off of a coil and another two capacitors forms pi network. So I got to kind of pick and choose on these. Let's get the meter out and see if we can find one that's as close as we can. Those are 470s that I pulled out of the bag, or pulled out of the box. We'll see how accurate they are. If I can get up something closer to 510, I'll be happy. Yeah, that one's 495. Okay. We'll set that over here. I'm looking again just to see if there's anything I might. I know I got a 500 in here, but it's so big I don't want to use it. It's monster. Yeah, let's just go through these. Hang on, folks. I think there's a lot of them here. Let's just do a little speed through this. And putting the higher ones up above the pile there. The ones that actually match are going up in the left, and the ones that are kind of close go down to the bottom left. Oh, there's one that's close. That's 501. Yeah, I think the best I'm going to do is at 501. That'll do. I think that's close enough. All right, everybody back in the bag. And poke it in the hole. Forgot where it was. And the next one is at C13, I guess. I think that one's 1500, 1,500 picofarad. I did some digging around. See if the greenies are any good. I don't know. But since we're 16, that's supposed to be a 1.6. Yeah, okay. Close-ish. Another greenie. Greenies are pretty good. They're stable. 1.6. And what's this one? 1.6. Yeah, well, they're also accurate, evidently. Let's try one of these. Just plain old ceramic. 1.468. That'll work. So, not accurate, but accurate enough for what we want. Unfortunately, that's also in that Pi network for the 57 kilohertz low pass filter, and it's not an NPO or NP0. So I don't know. We'll see. Temperatures don't change too bad. What's next? R7? No. C12. There we go. C12 is 390 picofarads. That's a standard value. In it goes. And, what's next? Sorry about the glare. I have to be able to see this. Yeah, let's just solder in what we got. Okay, all soldered. Cut my head out of the shot that time. You should be glad. What do we do next? I don't know what. C8? Yeah, C8. That's going to be what? Geez, I don't know right off the bat. C9. C8 was 0.1 microfarad, and C9 is going to be the same, 0.1, so stuff those two. And then down there is C6 and C6. And that would be 100 picofarad. Here we go. Come on. There we go. and give it a test just to make sure it's close. I do test most of the stuff that I put in. I'll test, but I've already used a lot of stuff out of these out of this box, and the ones that I bought a long time ago, I've used many of the components, and they all seem to be just fine. I've never had any bad ones yet that I know of. What are we going for now? C7. C7 is going to be what? 10 picofarad. It's got to zero out the meter for this one, I think. Come on. 7 high. Point 8, 0.7, 0.6, 0.5. Come on. A little more. Oops, stop. You got it. Except for your fingers. And we got 9.9. Pretty good. 10 picofarad. And that one actually is goes across the crystal, the 38 kilohertz crystal, so it's got to be kind of accurate also. That darn crystal, I had to order those and they're not here yet. So what do I do now? Well, solder it up. There we go. All soldered. And any more caps? No, not little ones, not that I see. Yep, okay. So it looks like we're off to electrolytics. What does these things call for? Oh, let's see, that's a C10. That's going to be 33 microfarads, 16 volts. I don't have any in that big box, so I got to go to this box. This is a whole assortment that I bought for really cheap. They've tested out pretty good so far. I've run them through voltages and their rated voltage and their capacitance, and they seem to be just fine. Yeah, that one's 33 also. Just for grins, I'm going to test this one. Yeah, 28.9. They're 20%. They're fine. They're just filter caps for the DC line. So it's not a big deal. Yep. Just making sure I'm getting it in there the right way. And this one, the negative's marked with the white bar. And what's this other one? It's going to be what? 1, I think. No, 10. Yeah, 10 microfarads. That's good. That would be like on pin 3 of the IC, going to ground, and then the output is another 33 mic. That's C14. So, okay. And solder it all up without head. Done. Missed something. Yeah, it looks okay. All right, well, put this stuff away. And now we come in with pots. These are little trimmer pots. I bought a whole grab bag full of them. I think it was $5 or something. And sat down and separated them all out into their individual little portions in this box. I had to actually print the extra separators. So we're going to go for the first two. Those are RV1 and RV2. And those are, what, 10K a piece? Find something that fits in here and looks good. And no, that ain't going to work. Come on. Got to be something that looks good. Yeah, it took me a while to go through all of those. And measure them, of course, to make sure they were still good. These little white ones look interesting. Will they fit? They definitely fit the holes and the size. If this one will fit next to it, we'll be doing good. Ha! It looks like I designed it that way, doesn't it? Did it? Yep. Look at there. Wow. Perfect. Okay, that's the last perfect thing that's going to happen on this build, probably. Okay. And solder those guys in. Done. All right. What's next? I'll clip the leads off, I guess. And then we got that one up there. That guy is the 57 kilohertz low pass filter adjustment, and that is a 50K for subcarrier. Subcarrier balance, it says, is what it says. I went through a bunch of them. I didn't show that part, but I finally came up with this one. It has to fit in the slot provided, and this is the only thing I could find. Like I said, no matter how many parts you have, you're never going to have exactly the one you need when you need it. There. And that next one, that's going to be RV3. And that is RV3. Yeah, no, that's 50K. The other one was 10K. Yeah, that other one there, that was RV4. That one was 10K, the stand-up one, and now we got this RV3. Don't have anything in the 50K pile that will fit in that slot right there. So I'm going to have to bend things around to make it work. Yeah, that'll work. And it's a 10 turn from the top. That's like I said, that's the subcarrier balance. The other one was the 57 kilohertz output level adjust, going into the transistor. So where the cutoff is on the transistor. So what's next? Yeah, we got what the RV5. RV5 is just level output. That's 5K. Got to find something. I got a lot of 5Ks, but I don't think I got. Maybe this one. It'll fit. I mean, the legs are right. Oh, let's try it. No, it didn't fit. This little yellow one will. Another 10 turn. That's definitely not necessary. But it'll fit in the hole. Yeah. Well, it does fit. Just got to straighten the legs out a little bit. Get them down through there. Ooh, that is close to that resistor, but I wonder if I can actually even make it, get a diddle stick in there to turn it. Yeah, I can. Okay. That'll work, I guess. All right, so what's next? Coil. We got a 4.7 millihenry coil over there to put in, and that's one of the things I had to order. That. There we go. Okay, that's in. And hack off the leads. And what else? Something else. I'm missing something. And that darn crystal, 38 kilohertz. Still waiting on that one. Straighten that up a little. Must fit flush on the board. You know, these pots all turn good. I'm just doing this because when you heat these little flat packs up, sometimes they lock up on you. Make sure they don't. Well, that's what I'm missing. Connectors. I'm just going to put a bunch of these two-pin connectors on here. That's what was in the schematic for the footprint. That's the word I was looking for. So, and they fit just fine. It's much cleaner than just running wires to your project box. Oops. Yeah. I don't have any blue sticky stuff to hold these things down. I've never done it that way. Probably should. I mean, when you think about it. Head. But that was quick. There's another one. Actually, there's a bunch of them on here. You got power in, both ends, an out, and a mute. Yeah, and a mute. So you can mute it. That's on the chip. It's all on that 23. Well, I forget what this thing is. It's 2035, NJM 2035 chip that goes in here. And it all runs at 1.5 to 3.5 volts. Okay, so put in the mute one. Probably don't even need this, but just for completeness sake. Well, I'll tell you, when you make the cables, the wires that go into these little plugs on the female side of these things, you really do have to have the right little crimping tool, because boy, are they, yeah, they're finicky. They're hard to get them right, even with the right tool. Seems like every time you get a new connector, you got to have the right tool. These, of course, are easy. And that's power. Tack it on, and then solder it down. And one more for output. This is for the composite output, which is all of the pieces of your audio and 19 kilohertz all smashed down into one signal. One of the reasons you do this is so you can do stereo over a single studio transmitter link transmitter. In the old days, if you want to do stereo, you had to have two transmitters. If you didn't do composite, you had to have two transmitters, one for left, one for right. Well, now you do it composite like this, and the other end separates it out for you in the transmitter, along with the pilot, the 19 kilohertz. That ain't going to work, folks. That's bad design, bad implementation, something, I'm not sure. Well, got to take that out. And it looks so good. Yeah. All right, well. Now I got to find something that will fit in there. And that one's 5K. I got a lot of 5Ks, but yeah, search. Okay, I searched for quite a while, and finally, this is what I came up with. I think this will work. If I can get the pins in the holes without dropping it. Jeez, fumble fingers. Why is this so difficult? All right, try number 7. Or something. Attempt. Oh, on the 3rd attempt, or 5th, or 9th, or whatever the heck it was. And solder that guy on to it, and we'll be off to the next challenge. And the next challenge is going to be the transistor. The transistor. Almost forgot about that. Got to find my transistor box. Here it is. This is another one of those purchases I did a long time ago when I saw one of those things that said 10,000 transistors of different kinds, $9.95 or whatever. And it wasn't quite that good, but I bought them and been using them up ever since. We're just going to use a regular old 3904 in here. Just a little old NPN. Simple NPN 3904. Because it's got plenty of gain, and this particular application that it's in, it's got plenty of it says only 57 kilohertz filter section, so bandwidth is not a problem. And and they're dirt cheap. And I was able to actually find the footprint and everything in Kicad, so I could just plop it down on the board, and there it was. But we're going to test it just in case. These little test everything testers are a great thing to have in your shop, man. I'm telling you, they're for just spot checking things, they're absolutely fantastic. There we go. Perfect. And for $20 or whatever they cost, you just can't beat them. And yes, you can build one yourself out of an Arduino. What can't you build with an Arduino? The programming is available out there. Form it up a little bit here so it'll fit in the holes. Still, I mean, I have to jam it down between those two pots. Should have done this before I put those pots in, but I didn't. Little fumble fingers here is not having a good day anyway, so. Gee, come on. 1, 2, 3. Got it. Okay, well, that's in. Clip off the leads. And we'll see what's next here. Yeah, I know what's next. And this is the mistake I was talking about right there. I couldn't find in the footprints anywhere what I needed, which is this. 22 millihenries maximum adjustable coil. I found that one, I believe it was on DigiKey. And actually, it got here in a reasonable amount of time. It was only a few bucks. But finding the footprint for this, so we're going to have to make our own. I put some holes in the board, but they're not going to work. We got to look at this thing and find out where is it connected to. This one has 5 legs, and the only ones it's connected to, I can't see it. Well, it's got to go down here someplace, and like right there. Now, which legs have the wires attached to them? I can't. It's really hard to see. I think it's the outside 2 of the on the 3, the side that's got 3 legs. I think it's the outside 2. But let's give it a shot and find out. That's what the meter's for. Hello, yeah, right there. One on the left, one on the right, and the center's not connected to anything, and the other side doesn't have anything on it either. So 21.8. Hey, that's cool. And it should be variable, hopefully down to around 15 or so. I don't know. I just bought what I could. 15.7 to 28.5. Okay, so it's about right. Hopefully it covers enough area. Let's put this thing somewhere in the center. Just, like 18 or something. Good enough. Now we got to figure out how to mount it. Think. I mean, we don't have to make this thing like it's going to go through a war, but it does have to at least be down on the board and not fall off. I wonder. No. I got an idea. We're going to drill holes in the board. Yay. But where? Well, I think probably facing me would be the best bet. Get out the little Sharpie and mark the holes. Yeah. Yeah, I think so. Because that way I'll be able to connect it directly back from one and also to the other. Got to remember that there is a trace in the top of the board that goes over to that RV5. So, yeah. Yeah, I think this is going to end up going right through the pad, but that's probably a good thing, actually, if you look at it. Okay. Well, this work, and I'm going to drill holes in the board. Hopefully I don't break anything. I don't want to drill through my mat, but let's get it. There we go. Pick it up and do the rest. Yeah, they're not perfect, but they're close enough. If I redesign this board, if I have any reason to redesign this board, I'll see if I can't make or find a footprint for this can. Okay, there's the two holes for the leads, but now we got to put a couple of holes in the sides there because there's wings off of that can that I can fold over to brace it a little bit, hopefully. Whoops. Are you sure? Yeah. Yeah, it's going to go right through that. Okay. I'll just wire around it. Okay. Yeah, see what I mean? Got to make sure it's not touching, though. And I got to get rid of the legs on this thing because I'm not drilling 5 more holes. or 4 more holes. Sorry about this. You can't see it, but I'm just sort of investigating. Yeah, the only thing I can do, I'm gonna cut the 2 on the other side, which have nothing connected to them, and the middle one on the front side has nothing connected to it, and leave it at that. This is not perfect, but it'll do. And yeah. Now for attaching of the wires. What am I going to use? I don't know. How about some wire wrap wire? That'll work. 32 gauge or whatever it's called. That little bitty stuff. Yeah, this is part of the 19 kilohertz bandpass filter. This 20 millihenry choke coil, adjustable coil. It's another Pi network. And I got to make sure that that trace doesn't hit the can, because that would throw everything out. The can is not grounded at this point, but still it would put a load on the on one side of that coil, and that wouldn't work. So let's see if come on, where's the meter? There it is. Okay, and yeah, it zeroes out, and we're testing across where that. Okay, so it is not shorted to the can. That is good. It's just exactly what I want. So let's solder down a little chunk of wire on one end, and on the other end, you can just solder through this stuff. You don't have to really strip it. It works just fine. Okay, so we got to get the other side too, but that's just a little jumper straight over, so that'll be good. And one end, and now the other end, just solder it down. And hold the knife on it, wiggle it around a few times, and it comes right off. Okay. Well, there it is. All put together except for that crystal. Anyhow, well, that's the end of this one. When we get the crystal in, we'll do the rest of it, and we'll test it, and we'll see if it works. Hey, thanks for stopping by. Don't forget to like and subscribe, and we'll see you next time.